Okay, good morning, everyone. First, a reminder. So we will have our first problem set on the 27th. That's a Wednesday. It will come live on Canvas at 8 a.m. And then pwede nyo siyang i-download and then you work offline. And just make sure to submit your answers again via Canvas on November 1st. That's a Monday right before midnight bago kayo mag-read, bago kayo pumasok sa reading break. So submit it via Canvas. So there would be 4 to 5 problems. And again, I will ask you to submit them individually. So bawat isang problem, isang submission bin kay Canvas. And my request is as early as you finish a particular problem, you try to upload it in Canvas para kung free ako ay masimulan ko siyang checkan, right? Or yeah, as soon as possible so I can give you immediate feedback. And also, if you worked in a group or may kinonsult kayo na material online or otherwise, please declare it on your papers. So para masanay tayo that we give credit to where credit is due. So if you found a similar problem in the internet and you drew inspiration from it, uh, just say it on the problem set or write it down. Wala naman deduction if you consulted some other materials, or if you did the group study for the problem set, then that's also perfectly fine with me. Just acknowledge the members of your group, all right? So, kaya nga, kung sa memes nagsi-CTTO kayo, ganun din sana sa lahat ng academic outputs, all right? And there would be no deductions for that, so I'll really appreciate it if you will include that in your submissions. And then, yeah, I think that's it. Also, you will have lab excerpt 3 due on Monday the 25th, and it will be about curve fitting. Maybe I can say a word or two about that later. So, but our main focus for today is to finish this module, module 5. And this will just be an extension of what we did last time for the case of linear fit, or the linear least squares fit. We said that curve fitting is another form of approximation, which is different from approximation because here we are treating error in a much more global sense. Hindi natin nire-require na mag-zero yung error sa nodes. Kung hindi, ang tinatry natin i-minimize ay yung total ng squared errors sa lahat ng mga data points. So, ibig sabihin, ang idea rito, kina-capture natin yung trend. Hindi local yung pagtrato natin sa error na dapat dumaan siya doon sa lahat ng given data points, making the errors at those data nodes to be equal to 0. Dito hindi. Mas global yung tinitingnan natin na error, hindi kailangan sakto, basta makuha natin yung pinakamaliit na summation ng squared errors all throughout the data set. Okay? So in a sense, we are capturing the trend of the data, and so we can use this curve fit as a forecasting method. So kumbaga sa interpolation, lagi lang tayong bound na doon mag-work sa interpolatory interval. Hindi mo pwedeng gamitin yung interpolating function mo dun sa labas ng interval kasi we don't have any hand or we don't have any control upon the error outside the interpolatory interval. Pero sa curve fitting, though wala rin naman tayong direct control, pero ang idea rito ay ang kina-capture natin or ang minomodel natin ay yung trend at hindi lang yung specific data points na binigay dun sa problem. Okay? So that's why at certain applications, and under nice conditions, ginagamit na pang forecast itong curve fit, especially if you have sufficient amount of data and then your data follows some trend na alam mo na ganito yung behavior niya. So, alimbawa dati, dun sa example natin last time, nakita natin na parang linear yung trend ng data. So, if the trend will hold, then we can use our curve fit, or if we can assume that the trend will hold for the rest of the x values, then we can use the linear fit na nakuha natin last time to approximate the function value at some point in the future or for higher values of x, right? So ngayon, titingnan natin ano kaya yung pwede natin gawin kapag hindi ganon ka-linear yung trend ng data. So in particular, we will look at the case wherein our data might have a quadratic behavior or a quadratic trend. And we will extend the derivation that we used last time in order to get the linear curve, the linear least squares fit to get the quadratic least squares approximation for a quadratically trended data. Okay? At makikita nyo, hindi naman ganun kahirap yung extension. And then towards the end, we'll also talk about extending it further into a more generic function. Right? So quadratic least squares approximation, as the name implies, yung set of candidate functions natin will comprise of p sub 2, which would be the set of all polynomials of degree, probably let's insert here at most 2. Kasi parang yun yung define natin as P2 when we talk about Legendre polynomials or Legendre polynomials. So dati ang S natin, ang class of candidate functions S natin ay linear functions. Ngayon naman, S will be taken to be the set of all polynomials of degree at most 2. So therefore, yung hinahanap natin na minimizer ng error will be of the form f hat equals ax squared plus bx plus c for some unknown parameters a, b, and c. So yung laman ni S ay mga functions na ganito yung itsura for real values of a, b, and c. And then we want to get the best fit among these candidate functions to a set of data x sub I comma y sub I. And this best fit will be measured against the L2 error of or the squared L2 error of against the data points. So mangyayari lang, remember, ang general formula natin sa squared error ay sum ng f hat of x sub I minus y sub I squared ay going from 1 to big N. All right? Palitan nyo lang si f hat ng ax squared plus bx plus c, then plug in x sub i's, so you get e. Now, this is a little bit different from the e that we saw last time, kasi yung e natin doon ay mx plus b lang, kasi mga candidate functions natin ay mga linear functions lamang. Pero rito sa quadratic least squares approximation, sila ngayon ay quadratic, so there would be 3 unknowns in the definition of E. So nakabase si E ngayon dun sa unknown parameters A, B, and C. And again, our goal is to minimize E with respect to A, B, and C. That is, find the values of A, B, and C that will minimize this sum. And again, from multivariate calculus, we know already that the necessary condition for a minimizer is that the partial derivatives will all become zero at those minimizers, right? So, kaya ko compute natin, itong mga partials, kasi equate sila kay zero. So, lahat na makakasatisfy nitong equations na to would be candidates for the minimizer, all right? So katulad lang din siya nung last time. So just a quick review or let's see, warm up siguro for the calculations today. Let's try to calculate the derivatives with respect to, say, A first, right? So dahil ang differentiation naman ay linear, so yung derivative ng sum ay sum ng derivative, so I can put the summation still here. And then I'll differentiate this guy. Pag dinifferentiate ko siya, siya ay something squared. Ang derivative ng something squared ay 2 times something to the first power. So it will become 2 times whatever the original base was, right? However, this is a function of A, so the chain rule will kick in. We need to multiply it by the derivative of the base. So ito yung base. I-differentiate ko to with respect to A, si y sub I, si C, at saka si B times x sub I. They are all constants with respect to A. So ang derivatives nila ay 0 with respect to A. So the only contributing factor or the contributing term to the partial derivative would be ax sub I squared. Ang derivative niya ay x sub I squared, right? Kasi remember, we are differentiating with respect to a. So, okay, so and that's how we got the partial of e with respect to a. Similar thing will happen if you get the partial of e with respect to b and with respect to c. And then if we do so, we'll get equation 5.17. Okay. Medyo nagkaiba lang sila dun sa multiplier galing dun sa chain rule. Right? So ito yung partial with respect to a, ito yung with respect to b, ito yung with respect to c. And then our goal is to solve for a, b, and c that will satisfy equation 5.17. Yung mga triples na yon, sila yung candidates para sa minimizer. Okay. Now, I think what I can do next is to manipulate that equation 5.17 a little bit further, and then transfer all those with constants on the right-hand side. I'll get equation 5.18. No, kahapon sa lecture, we discovered there's a typo here. So kindly correct the third equation. Dapat ito ay summation ng y sub I lamang. Let me just double check. Yeah. So ito ay merong minus y sub I. Pag lumipat siya sa kanan, magiging, I can divide both sides by 2 first. Tapos ililipat ko sa kanan yung summation ng y sub I. Right? So kaya may typo nga dito sa 5.18. So it's the last right-hand side should be sum from 1 to n ng y sub I. Okay? And probably it would be easier to look at it in a matrix form. Okay? But anyway, at this current form of 5.18, kaya nyo na siyang isolve by substitution or by elimination for the a, b, and c values. Okay? So, hindi ko na sinulat kung ano yung formula kay A, formula kay B, at formula kay C. You can derive those using using those usual techniques that you learn from algebra, or pwede pa nga mag-Cramer's rule, siguro mas madali to solve this linear system. Or you can ask your computing software in order to give you A, B, and C. If you're using Mathematica, you'll just put all this data in. Or if you are using MATLAB, maybe it would be easier to put it in a matrix form. Yung matrix form naman niya, madali lang din. So, try natin siyang isulat ng matrix form. So, the first guy will be, or the first columns will be those involving A, the unknown A. Second column will be those involving the unknown B, and then the third one would be for the unknown C. Sa first equation, ang may A lamang ay summation ng xi to the fourth. So that would be our first entry, xi to the fourth. And then second entry in the first row would be summation of x sub I cubed, kasi siya yung may coefficient na unknown b. And then third column would be sum of x sub I squared. Kasi ito ay mamumultiply ng vector of unknowns a, b, and c. Alright? So, check nyo to. Multiply nyo yung row by the column. Kunin nyo yung tawag dito, yung dot product nila. You will get the sum on the first equation. And of course, it would be equal to the right-hand side. We will not do anything more with the right-hand side. Puro constants lang naman yun. And then the second row, kung mapapansin nyo, ito ay kamukha nito, na iba lamang yung coefficient. Ito ay kamukha nito, na iba lang yung unknown coefficient. So essentially, the second and the third column of the first row will be repeated in the second row. And then yung pang tatlong column sa second row will just be summation of x sub I going from 1 to big N. And then yung sa third row naman, mauulit ito. And then the last column will be this guy, summation ng C. If a factor out is C, so summation ng 1 from 1 to n, and that's going to be just capital N, right? So ito yung matrix system para sa equation 5.18. So if you will be doing it in MATLAB, so you are actually solving some sort of an AX equals B. So you can ask your software to compute A inverse times B, and that will give you the values of the unknown parameters A, B, and C. Okay, but this will work if you are sure that A inverse is that A is invertible. Dapat may inverse si A. But actually, a sufficient condition to guarantee that A will have an inverse is that the exabytes are all distinct. Katulad na naging additional assumption natin with the linear curve, with the linear least squares fit. Because again, this system, this matrix system, will have a unique solution if and only if its determinant is not equal to 0. And the determinant of this coefficient matrix will not be 0 if the exabytes are all distinct. And again, it's a fair assumption because we are assuming we are approximating or we are modeling a function. So ibig sabihin sa isang exabyte, isa lamang yung makukuha nating data point. So that means if we have n data points and assuming that there's only one assigned value to each of the exabytes, then the exabytes must necessarily be distinct, right? So kapag kaiba-iba yung mga exabytes, guaranteed tayo na itong system na to will be, or this coefficient matrix will have determinant not equal to 0. Therefore, the system AX equals B will admit a unique solution. And that unique solution is A inverse times B, right? So ibig sabihin nun, isa lamang yung candidate natin para maging minimizer, right? So siya lang yung solution nung equation 5.18. But however, the function E that we are minimizing is continuous. So the extreme value theorem guarantees na meron siyang minimizer. So dapat meron siyang minimizer, isa lang yung candidate. So therefore, sure tayo na kung ano man yung masosolve natin out of equation 5.18 will give us the minimizer. Okay? So probably one good exercise is for you to try to solve this system with or based on this this values. Katulad ng ginawa natin sa least squares sa linear least squares fit na meron tayong explicit formula para kay A at saka kay M at saka kay B. So pwede niyo rin yung gawin para kay A, B, C kasi you can imagine everything here to just be constants. Use your good old, say, Kramer's rule. In order to get the solution, then that will be fine. Sa quadratic least squares fit naman, hindi nagbabago yung size ng system even if you have more data points. Kung napansin nyo dun sa cubic spline, habang dumarami yung points na ginagamit, lumalaki yung system na kailangan nating i-solve. Pero dito sa quadratic fit, kahit 100 yung data mo, 3 by 3 pa rin yung system mo makukuha. Alright? Kasi hindi naman nagbabago hindi dumarami yung parameters. Ang dumarami lamang, possibly yung data, so lumalaki yung mga values yung nandun sa loob ng coefficient matrix. Pero yung size ng matrix ay 3 by 3 pa rin. Kasi basta quadratic fit, tatlo lang yung parameters na hinahanap natin. Okay? So really, you can devise a generic formula para hindi kayo nagpapakompute kay MATLAB always. Okay? Pero I think mas madaling tandaan itong coefficient matrix na to. Maganda yung pattern. So kung meron din naman kayong calculator or computing device na ginagamit, it's fine. Every now and then, you just ask your program to compute A inverse B. All right? So any questions with the derivation? So I hope the way we derived the linear and the quadratic least squares fit makes sense because in the exercise and probably in the problem set, I'll ask you to derive a formula or the system of equations at least para sa, say, sa exponential o kaya sa linear curve fit. I will describe the process later, but essentially it will follow the same pattern with how we did the derivation for the linear and the quadratic least squares fit. Okay. So clear ba to? Or do you have any questions before we proceed to the example? Okay, so kung wala naman, okay, so let's look at our first example. And in example 5.3, I collected the data, or I collected as data the closing price of Jollibee stocks for July 19 to August 18, 2021. So actual data to. I will see it later in table 5.2. So I just used the exabytes to correspond to the day number in this period. For instance, July 19 is assigned x sub 1 equals 1. So yung data mamaya na makikita nyo na course yung y sub 1, siya yung presyo ni Jollibee noong July 19. And then x sub 2, the second data point that you will see in the table, has x sub 2 equals 3, corresponding to July 21. Wala akong x na equal kay 2 kasi yun ay July 20, parang non-trading day yung July 20. I think it's on a weekend, so kaya wala tayong available data there. Up to the 22nd data point, yung pang 22 na data point na makikita natin sa table mamaya, it corresponds to an x value of 31, and that would be for August 18, 31 days after July 19. So basically, nag-observe ako ng isang buwan. Ano yung mga closing price ng Jollibee stocks? And you will see it in table 5.2 here. So that means on July 19, first day of our observation period, 210.6 yung presyo niya. On day 3 of our observation point, which happened to be the second trading day within the observation period, 204 pesos yung presyo niya. And it went down, medyo downward yung trend. Kung mapapansin nyo, kasi day 31, naging 194.80 na lamang siya. Right? And then, so here are the exabytes, these are the y subies. Using these values, I can construct this coefficient matrix. And I can also compute the right-hand sides. Lahat ng information nasa atin na. So nawawala na lang talaga yung ABC, which we expect to compute as the solution of this linear system. Okay. Now, if you will do those calculations, you will find that equation 5.18 needs to be particularized to equation 5.19. So ito yung summation ng xi to the fourth, summation ng xi cubed, summation ng exabytes, exabyte to the fourth, sum ng xi cubed, sum ng xi squared, sum ng xi, ito yung value ni n. Right? Tapos ito naman yung mga right-hand side. And then if we will compute this, if we will compute for A, B, and C, you will find that A is approximately 0.041816, B is approximately negative 1.8, and C is approximately 2.09. Mga approximate values lang pala to kasi I think there are, the solutions are irrational. So infinitely many decimal digits. Kaya lang, of course, I can only display much. So parang 6 decimal digits lang yung ginamit ko rito. And so among the class of all polynomials of degree at most 2, si f hat, given by this equation, minimizes the L2 norm of the error, or the squared L2 norm of the error, or basically the sum of the squared errors. So ito yung best fit among the quadratic functions. Okay. I forgot to mention why we decided that a quadratic function would be a nice fit to the data. Ito yung usual nga pala natin ginagawa bago tayo gumawa ng computations. Usually, ipinaplot muna natin yung data points in a scatter plot para makita, at least visually, ano yung trend or ano yung behavior ng data before we decide ano yung mga class of candidate functions that we will use. And in this case, pag pinlot yung data sa table 5.2, ito yung magiging scatter plot. Okay? And then you will see here na hindi ganon ka-linear yung behavior ng data. So it makes sense to try a quadratic function kasi yung part na to parang nagre-resemble siya ng parabola. Meron nga lang tayong ilang mga isolated points. But again, we are not directly concerned with a good error at each of the points, specifically at the outliers. We are modeling the trend. So nangyayari, gusto kong mag-fit ng isang quadratic function na dadaan at most, sorry, parang daraan siya or malapit siya sa karamihan o majority ng mga data points. Okay? Now, if we will plot the function f hat that we computed after the minimization procedure against the data points, ito yung makukuha natin. And true enough, this f hat passed through generally near the data points, and again saving the outliers kasi nga ang minomodel natin dito ay yung trend. Okay. So with this knowledge, dahil yung trend yung ginagamit natin, we can use f hat to be a model for the closing stock prices at any point in the observation period. So kung gusto nating i-test, halimbawa, kung ang July 20 ay trading day, ano kaya yung posibleng closing price ni Jollibee, assuming that the trend is carried on. So ibig sabihin, i-compute ko lang si f hat of 2. And this is something that we could have done if we interpolated this function, right? Kasi si 2 ay nasa loob ng interpolatory interval. So, yun nga lang, yung function natin, ang posibleng itsura niya ay, di ba magko-connect the dots tayo, polynomial. So, baka ganito yung maging itsura nung interpolating polynomial natin kasi daraan tayo sa lahat ng data points. Pero dito sa quadratic fit, hindi kailangan dumaan yung ating approximating function sa lahat ng data points. What we are after is minimizing the global measure of error. And again, since we strive to capture the trend, so if we can assume, or if it would be a fair assumption to assume that the trend is carried over for higher values of x, then we can use this data in order to forecast what would have been the closing price yesterday. So ano kaya yung f hat of 95? Kasi kahapon ay, kung tama yung pagkakabilang ko ng araw, 95 days after July 19. So kung i-assume natin na quadratic talaga yung trend ng stock prices ni Jollibee, so ibig sabihin ng estimate natin sa closing price niya ay 208 point, I think it's 208.18 if I'm not mistaken. So ipa-plug in nyo lang naman si 95 kay FAT. So hopefully this is right. Kindly double check me. Kinompute ko to kahapon dun sa kabilang klase. I hope I didn't murder the number kung tama yung pagkakatanda ko, right? So which is a little, hindi pala a little, medyo malayo siya dun sa actual stock price yesterday. The closing price yesterday is around 230. I think it's 229.8, which is about 10% on the ballpark of 10% error. But again, the reason there is kasi naman ang stock prices ay hindi naman talaga quadratic yung trend. Nagkataon lang na from 0 to 31, okay? From day 0 to day 31, almost quadratic yung trend. Pero ang stock prices, jagged yung model niya, right? So, kasi medyo random yung paggalaw ng stock prices, right? So, walang specific model for it. So, kaya hindi maganda na gumamit ng curve fit, ng quadratic fit. Or posible kasi yung 95 is too far out from our data points. Ang max data point natin ay 31, ay x equals 31, pero to ay 95. So there might have been several things that happened between 30 and 95 na hindi na-capture nung ating given data. So again, this curve fit will be better if you have lots of data or lots of information and the trend is followed. At parehas ng nice characteristics na yun or nice requirements for a forecast ay hindi ko na-satisfy kasi nga konti yung data ko. And again, hindi naman talaga quadratic yung trend nung stock prices, nung minomodel ko na phenomenon, right? So it would have been better if we have more data, siguro prior to 95, makikita natin yung data points, ma-observe natin ano yung trend. At makakapag-decide tayo kung appropriate pa nga ba yung paggamit ng quadratic trend or ng quadratic fit. Maybe a logarithmic fit or an exponential fit might be better. Okay. So, but I hope you get the point, right? Now, to see how well we capture the data, the trend using the quadratic trend or using the quadratic function, we can calculate the relative error or the relative root mean square error. So ito yung resulting ito ay yung resulting squared errors. Gusto nating makita ano yung percent error on the average. So itong sum, i-divide lang natin by the number of entries. So ito yung average squared errors. Kunin mo yung square root niya, makukuha mo yung average root mean squared error. Okay? And then i-divide mo siya by the size of the actual data we're trying to calculate. Okay? So, kaya makukuha natin yung percentage error. Parang dapat pala walang mga tildes to. Dapat y sub i's lang. Kasi balikan ko lang yung table 5.2. Yeah, y sub i's yung nasa data column natin. So, dapat yung nasa computation ng error ay mga y sub i's. Right? So if you calculate this ratio, you'll get something around 0.0181. And this can be interpreted as the percentage error on the average. So you can say that on the average, we think our model is accurate at around 1.81%. And again, this is on the average because you will see here na, sir, bakit 1.81% yung error? Tingnan nyo tong sa around sa value na to. Napakalaki ng error. Posibleng hindi lang yan 1.81%. That might be true, but again, in least squares approximation, we are minimizing error on a much global sense. So, ibig sabihin, tinitingnan natin ano on the average yung error. So, because here, for instance, at this data point here, siguradong mas maliit sa 1.81% yung error. So, yung sinabi natin na relative error on the average siya. On the average, sa bawat point, ang error ay 1.81%. Not everywhere, but that is the average for relative error. Okay? And that is actually that is quite nice. Masyado mababa na ito, etong 1.81%. For most applications, this will suffice. And this will suggest na kung talagang quadratic yung trend ng data, ibig sabihin maganda siyang gamitin pang forecast. Kasi it was able to capture the behavior of the data points that we have with error of just 1.81%. Okay. Now, okay. Any questions pala doon? Kasi yung susunod na figure, iba na yung dinidiscuss yun na example. All right. So if there are no questions, then tinry ko sa susunod na example na gamitin yung quadratic, yung strategy natin for a quadratic fit para humanap ng quadratic fit dun sa data natin sa table 5.1. Remember yung data natin sa table 5.1, yung consider natin sa linear least squares approximation, ay itong mga blue dots na to. And we said last time na this is very suggestive of a linear trend. Okay? Now, ginamit ko yung formula yung equation 5.18 para humanap ng isang quadratic fit. And actually, the quadratic fit that I got ay halos kamukha na nung linear fit. Because in graph 5.12, we should have seen two curves, the linear fit and the quadratic fit. Kaya lang yung linear at saka yung quadratic fit almost nag-coincide na silang dalawa. And unfortunately, I forgot to display exactly what A, B, and C I got for after using the quadratic fit. Pero I think dahil kung makikita niyo yung quadratic fit ay almost aligned, if not exactly aligned, then I'm guessing that the A value that I got from that linear system is close to zero. And this is due to the fact that we didn't restrict A to be non-zero. So definitely if linear function yung best na mag-fit dun sa data, then our equation 5.18 will give us a value of A very close to zero. And I think that is what happened here at this particular example. Kasi nakita nung model natin na ang nakakapag-minimize kay E, kahit yan ay function of A pa rin, ay isang linear function. Okay? So, ibig sabihin, covered tayo. So, pwede mong palakihin yung class of functions para ma-capture or para para mag-giveaway para sa iba-ibang mga trends ng mga data. So, ibig sabihin, yung na-develop natin sa quadratic least squares fit, it can be used whenever your data has a quadratic or a linear trend. Kasi nakaka-capture niya yung quadratic polynomials of degree less than 2. However, the converse doesn't happen, as we will see earlier. But before that, let's take a look at how different are the linear and the quadratic fit that we got. I think their supremum error is just about 8 times 10 to the minus 3. Pag kinuha ko yung yung linear fit minus quadratic fit, kunin ko yung absolute value, ang pinakamalaking absolute value ay 8 times 10 to the minus 3. Or if you compute the L2 relative error, or which is a good measure of how far the linear from the quadratic fit is, makukuha natin ay 0.29% lamang. So talagang magkamukha yung nakuha natin from the linear fit and yung nakuha natin if we use the quadratic fit. Kasi nga 0.29% lang yung pinagkaiba nila. Okay? And actually iba na pala yung nandito sa figures sa baba. But the converse doesn't happen. Because if we will try to get a linear fit using the data, the Jollibee stock prices that we have, na inassume natin to have a quadratic trend, ito yung makukuha natin, yung nasa figure 5.13. Yung red, siya yung linear fit, yung yellow, siya yung quadratic fit. Okay? And you will see na, okay, at least visually, hindi tayo makapag-decide kung ano yung mas magandang model, yung bang quadratic o yung linear fit. So to give us a more to give us a better insight of which did better, computed nyo yung relative root mean square error. Yung relative root means yung relative root mean squared error para sa quadratic fit ay 1.81%. Pag kinompute natin yung para sa linear fit, it's 2.41%. So based on this number, on the average, mas maganda yung binigay ng quadratic fit. Mas maliit siya by about 0.6% or 0.6 percentage points, which might matter in some applications, right? So kaya really, a quadratic fit is better. Okay. So I think that that ends the discussion of quadratic fitting. Any questions? Hopefully clear naman yung process kung paano siya kino-compute at paano nagagamit yung data. Then I guess in the module we had several examples or several illustrations on how to present your data or the results of your calculation. So baka magamit niyo yung ganitong presentation sa problem set. Okay, if ever I'll ask you to do something like this. Okay. So the rest of the module describes what will happen if you want a more general fit. Kasi nga hindi lang quadratic. Halimbawa, gusto mo magkaroon ng degree 10 na curve fit, or you want say an exponential or a linear fit. So paano siya ginagawa? The process is very similar because the extension of what we did is natural. Mula dun sa linear, quadratic, papunta sa iba pang mga klase ng mga functions. So let's take a quick look at how it is done in general. So halimbawa, yung class S of candidate functions natin, ganito yung itsura. Linear combination siya ng sum ng ilang mga functions, okay? So yung mga size dito, psi1, psi2 until psi_m, ito yung mga known functions na gusto mong gamitin dun sa pagmo-model. So in our case, sa linear fit, si m ay equal lang kay si m ay equal kay 2 kasi meron lang tayong dalawang terms. AI times this would be a constant AI sorry, parang B yung ginamit natin sa linear fit. So it's a B times psi1 is the constant one. And then A2 is your slope times A2 was taken to be X. So ang unknown parameters natin doon ay si B at saka si M. So quadratic fit, meron tayong A times 1 plus B times X plus C times X squared. So ang A1 natin ay si A, ang A2 natin ay si B, si A3 natin ay si C, tapos ang psi1 ay constant function 1, si psi2 ay X, si psi3 ay X squared. Okay? So kung gusto mo ng X to the fourth, then si psi1 ay 1, si psi2 ay X, si psi3 ay X squared, si psi4 ay X cubed, si psi5 ay X to the fourth. Okay? So, ganun yung idea. So, mas general nga lang to kasi si psi pwedeng exponential. Halimbawa, si psi1 piliin ko to be e to the x. Si psi2 piliin ko na e to the 2x and so on. Pwede rin naman sila ay mga sine functions, sine x, cosine x. Bahala kayo kung ano yung mga functions na gusto nyong gamitin dun sa pag-fit. Whatever that function is, so mangyayari ay, yun, ganun pa rin yung process. But this time, our error is a function of the m unknown parameters. And then if we will put that inside the formula, magkakaroon tayo ng summation nitong mga to, evaluated at the x sabays minus y sabay quantity squared. So yung itsura niya magiging ganito, summation siya ng I from 1 to n, ng summation I from 1 to little m, ng a sub I, iba pala dapat yung subscript dito, a sub j, psi sub j of m, of x sub I, minus y sub I quantity squared, right? So pinalitan ko lang si f hat by this guy, which I wrote using the summation notation. And then, ang gagawin natin ay kukomputin uli natin yung mga partial derivatives kasi yung yung pagiging zero ng lahat ng partial derivatives ay necessary para sa minimizer. So if you will, if this is e, if you compute the partial of e with respect, say, to a1, ito ay equals sa summation ng mga derivatives. Meron kang exponent na 2, bababa siya dahil nag-differentiate tayo. Then we'll just copy the base. Okay? Then chain rule will kick in. Mamumultiply siya ng derivative nung base with respect to a1. Kaya lang dito, ang may a1 lamang ay yung unang term lang. Ito lang yung magkaka-a1. So ang derivative nito with respect to a1 ay psi1 of x sabay. Right? Kasi lahat ng mga natitirang terms dun sa linear combination ay wala ng a sub 1. So pag kinuha mo yung partial with respect to a sub 1, ito lang yung dinidifferentiate. So variable a1 times something that is treated to be a constant, ang derivative niya lang ay yung scalar multiplier o yung tinitreat natin as a scalar multiplier. And you can do this for all j's starting from 2 to m, right? So pwede niyo ipagpatuloy yung pattern para sa partial derivatives with respect to a2, with respect to a3, and so on. Hanggang sa dulo, equate natin lahat ng yon kay 0. And what you'll get is a linear system that looks like 5.21. So ito yung equation na sinusolve natin. sa bawat isang unknown. O ito yung bawat row ng ating matrix system, right? So when j is equal to 1, you will get this particular case. Then when j is equal to 2, you'll get another equation, siya yung magiging second equation, that's the system, and so on. So eventually, you will have an m by m system, which will have a unique solution if the exabytes are unique. Okay? And then ang particular case nitong equation na to ay yung nabanggit ko kanina, kapag pag gusto mo ay si linear fit, gawin mo lang si psi1 equal kay x, saka si psi2 ay equal kay 1, tapos 0 na lahat ng other psi sub j's. Tapos pag quadratic naman yung gusto mong fit, take mo si psi sub 1 to be x squared, psi sub 2 to be x, psi sub 3 to be 1, tapos 0 na lahat ng psi sub j's with subscript greater than 3. Ang makukuha yung equation 5.21 ay yung mga equation na nakuha natin from last time at kanina. All right? But again, this is more general because we can choose the size of bytes to be any differentiable function that we want. All right? And I think that is one thing that you were asked to do in the lab exercise. Parang dito sa first problem, kailangan daw gawin ay power function. Okay? Pag power function, ang itsura niya daw ay ax to the n. So ibig sabihin, pwedeng ito yung gamitin yung psi. Kaya lang, ito ay magkakaroon ng dalawang parameters. Unknown parameter a at saka unknown parameter n. So kailangan yung hanapin yung best fit na magbibigay ng best fit with respect to the parameters a and n. So ang error function nyo nun ay sum ng axi to the power n minus y sub I quantity squared, I from 1 to big N. Tapos compute nyo lang yung partial derivative ni E with respect to A at saka partial derivative ni E with respect to N kasi sila yung mga hinahanap natin na unknown parameters and equate both to 0. Makakakuha kayo ng 2 by 2 system in the unknowns A and N. Tapos gamitin nyo siya, solve nyo yung system na yon. Okay, linear system lang naman yung lalabas. So, linear system nga ba siya? Yeah, I think linear system lang naman yung makukuha nyo. Or at most, isang simpleng non-linear system. So, you can either solve it by hand or ask your software, MATLAB or Python or Mathematica to compute the values of A and N for you. Okay? Siguro sa lab sa problem set, baka ang gamitin kong class of functions ay exponential and logarithms. So at least hopefully by then you can compute the you can write down the system that will give us the unknown parameters. Okay? Tapos yung process katulad din lang naman yung ginawa natin sa linear at saka sa quadratic fit. Okay? All right. So I think that's it for today. Do you guys have questions? Or may mga concerns ba kayo about the problem set? Though last time di na kayo nag-react, so almost final na siya in my mind, unless you have very compelling appeals today. May mga appeal na pa ba kayo? Okay, so kung wala na, so that's it for us this week. So thank you guys for joining me early this morning. So enjoy the rest of your day and your weekend. Prepare for the lab extra on Monday and for the problem set next week. Sorry kung medyo nagsabay sila sa isang week, but okay lang yan para sa reading break, wala na talaga kayong iniisip. You can have the whole week to relax and re-energize para sa second half na ng semester. Okay? So really, no other concerns? Okay, so that's it, guys. Thank you for coming and see you on Wednesday. Bye, guys.
Thank you, sir.
You're welcome.